Hi friends, I'm back with another video. Last time we closed the video on the note where we mentioned that how clients actually know to how to reach the server addresses, right? How every client on the internet, whether it's a mobile phone or whether it's a laptop or a desktop, how these millions of devices acting as clients reach to their servers, which are let's say web servers like Yahoo, Gmail, or any other web server for that matter, right? For any front end to back end application, or in fact, all applications behave in the same manner. There is a front end and there is a back end, there is a client, there is a server, right? So, how these clients actually connect to the servers, that is the question which came to our mind last time, and that is the mystery we are trying to solve over here in this video today. So, let's take a scenario. Let's say this is your laptop, this is your browser, and you're trying to connect to www.google.com. Okay, then how does somehow it is, you know let me create a laptop like this. Okay, so now this laptop, okay, how does know where is the address of this particular Google server, right? Correct. Now that is the mystery we are trying to solve. Now everyone knows that every device, whether it's a internal network or a internet, a laptop, desktop, mobile, every device has an address which is called as IP address. Right? I don't think so that I need to explain this to anyone. This is very basic, and everybody knows that every system, every laptop, every mobile has a IP address. This IP address looks something like this, like 10.1.1.1 or maybe 192.168.1.10, something like this, right? It has basically four octets which we see, and these four octets represent something, okay, uh, which cumulatively creates a IP address, right? Now, one thing you need to remember is that these IP address, although they may seem as if they are decimal, okay, but they are not decimal actually. They are uh, binary numbers. This is for our convenience. We write the numbers in these format, but actually, if I try to interpret 192 over here, 192 would be written like something like this: 11000000. Okay, I'm not explaining you the logic behind this, but I'm just trying to tell you or explain you that whatever IP addresses you write or what you see in your system or servers, those are actually binary. Those seem decimal. That is only for our convenience. The computer, your laptop, or your client actually converts into binary and then uses it. Okay, so going back to our scenario where this client is trying to reach this server, and somehow only thing was which was typed in the browser was this address www.google.com, which is of course in characters, right? It is not in binary, it is not in decimal, right? It is not in binary, not in decimal. That means there should be a mechanism where this address should be converted into binary. Okay, now that conversion of host name to an IP address which is binary is done by a specialized server called as DNS, domain name system. This is a specialized server, a magical server over the internet, or over the intranet also, I should say, which actually does this conversion of converting the host names to IP address. It also does the reverse way, IP address to host name, but we'll not get into that. Most of the world works only on host name to IP address, what we see. Okay, so how does it happen? How does it look into action? That is what we'll try to see over here. What happens is that any computer or a laptop, I'll make a laptop or a computer in a square way now, otherwise it will you know auto adjust and create some new shape. I don't want that to happen. So let's say this is a laptop or a desktop, right? And the moment you type www.google.com, this laptop or desktop gets confused. Okay, out of confusion, what it will do, it will try to look for a DNS server. As I told you, DNS server is a server which resolves host names to IP address and IP address to host names. So it will look for a DNS server, but from where will it get the address of this DNS server, right? It's very simple. If you go and check any laptop or a desktop under TCP IP settings, you may find four or five fields. Maybe one is IP address, second is subnet mask, third is default gateway, fourth is DNS1, then DNS2. So these are actual IP addresses which are there in your system. So for example, I can show you currently on my laptop. Okay, when I go to my, I'll show you. Wait. Okay, so if I go to my Wi-Fi settings, okay, and if I go to details, if you see, there is a TCP IP settings. I have an IP address, I have a subnet mask, I have a default gateway router, then I have something called as DNS. So this address which you see in front of you, 192.168.1.254, this is my DNS server. That means my laptop, when I'm trying to go to any website, it is actually connecting to this server. This is actually my router, my home router, or the next hop. Okay, it will connect to this server and actually ask for the address. For example, let's say if I'm typing here dot yahoo.com, right? What happened is that my laptop actually connected to this server which is there in the DNS settings, and it actually asked a question to that DNS server, asking that where will I get yahoo.com, and the response which was received was this. So for example, if I do a ping yahoo.com, again I'm actually resolving the address of yahoo.com. Okay, that means my laptop will again connect to the DNS server and ask for the actual IP address, which is this, and using this IP address my laptop is actually connecting to the yahoo.com server. So for example, if instead of putting yahoo.com, if I put this IP address itself, not the URL, that means now I'm bypassing DNS, I'm just directly putting the IP address. What will happen is that it is giving me some kind of an error. This is basically my browser security, where browser is understanding that whatever I have typed over here and the server, the certificate presented by the server, the names are different. That's the reason it's giving me a warning. I'll just ignore this warning and I'll say proceed to this IP address. Okay, and Yahoo is pretty smart. Basically, it is not directly allowing me using a IP address. It does say Yahoo will be right back, but let's say yahoo.com, and I did a ping to yahoo.com. Let me fix this. I'll do the ping to the actual host name. I actually did it wrong. I pinged to yahoo.com only. Now I'll ping to Yahoo, www.yahoo.com. Okay, so this is the actual address. So my mistake. So what I'll do, I'll use this IP address. Okay, and I will paste it over here. Let's see what happens. I hope this time it works. Advance, proceed. Oops, again the same thing. Okay, so Yahoo is pretty smart. It is blocking us. It is not allowing us using an IP address. Yahoo servers have some sort of additional security, I believe, which is not allowing me to connect using an IP address. Okay, this is smart. Let me take another example, otherwise you will feel that okay, I'm teaching something which is incorrect. This time let me take gmail.com, or let's say google.com. Simplify. Maybe they may not have this kind of security. I'll just do a ping to www.google.com. Okay, I'm getting some IP address. Let me try this. So ideally, google.com page should open using, oh sorry, IP didn't change. Wait. HTTPS. Okay, enter. Let's see what happens using this. Ideally, a google.com page should open when I proceed. Ah, great. Okay. So Yahoo does not allow you using an IP address to connect. That is something I learned today while creating this video. But Google does allow you directly using an IP address to hit their servers. But if you see what happened over here, Google did something good over here. It actually changed the IP address to a URL in the browser automatically. Maybe they are doing some kind of a redirection. Okay. So this is how DNS works over the internet. Now, few things which I wanted to tell you. I'll go back to my whiteboard. Okay. So this is how clients basically always connect to the internet using a DNS. Now, before that happens, always you should remember that a client actually follows 2 3 steps before it actually connects to a DNS server. It first looks into the cache, whether it has something which is in cache. Okay, that means if you're visiting google.com once, and again if you're trying to visit google.com, the first time when the browser visited google.com, it will store the details of google.com, the page, the details, the IP address, everything in cache, so that it can retrieve in cache. So first is cache, second is a host file. There is a host file in the operating system, I should say, which has entries where you can manually point the host names to a different IP address. For example, here if I am getting a google.com IP address, I can go in the host file and change and write google.com, and against it I can write some other IP address. For example, in the host file, if I make an entry like this, it is something like this, 1.1.2. Okay, if this entry, if I'm making the host file, what will happen is that my browser will always try to connect to this IP address when I type www.google.com. Okay, it is like overriding the DNS part, and it will not go to the DNS at all. Okay, once it crosses the host file, if there is no entry in the host file itself for that particular URL where you're trying to reach, then it will try to go to the DNS. Okay, so keep that in mind. Now next thing is that the DNS, I'll give you some more knowledge, but not to confuse you, but it's important how DNS actually works. Now this DNS server which I mentioned, right, on the DNS server which it connects, what it does is that, wait, let me just remove this. Okay, okay, what it does is that now it is, you saw that my system was pointing to a local 192.168 DNS server, right? Now that will that may or may not necessarily have the address of google.com. Okay, but in that case what can be done is that if it doesn't have the address of google.com, it will actually go and find out the address of google.com. How it does is that it actually goes to some root servers over the internet. We call it as root servers over the internet, which has all the top level domains registered. Okay, the top level domains is dot, one moment, sorry, top level domains is .com, .org, .in, .uk, etc. So these top level domains, so these root servers will actually give back to this DNS the address of these top level domains. Again, the DNS will come to .com, because you can see that it was google.com which was searching. Again, .com servers may not have the address of www.google.com, but definitely Google is registered on .com, so it will give you the address of google.com DNS servers. So then again it will connect to authoritative servers of Google. Okay, and this google.com authoritative servers will actually respond with the address of www.google.com. This all happens within milliseconds, ideally within 50 milliseconds, right? Instantaneously. You actually don't come to know, you don't realize that this entire process is happening at the back end. So keep that in mind, that DNS, and this DNS is basically called as a recursive resolver, because it is resolving for you, okay, the actual address of the server. Okay, apart from this, I also wanted to explain a few more things. For example, in a DNS server, when you say, let's go to another whiteboard. So let's say this is a DNS server. Now, ideally, when I mentioned google.com, it may have records. Records means entries, simple entries like www.google.com, and IP will be, wait, hold on. Okay, so this is the DNS server, and in that www.google.com, what IP we saw just now, it was something like 142.251.157.119. Okay, so this is like a record created. Now this kind of a record from name to IP is called as a record. What it is called? A record. Okay. Okay, and any record which is like this, let's say www.google.com, pointing to, let's say, another name, www.superman.com. This kind of a record which is pointing from name to name or a alias name is called as a CNAME record. Okay, that means the DNS server has multiple types of records which you can store. So I have only shown you a record, CNAME record. There are other records such as MX record, TXT records, name server records. Okay, that you can anyways Google and understand, because once you know the concept of a DNS server, which is actually hosting records and serving clients to reach the addresses of the servers, understanding these records will be very easy. Okay, so I think this is it. This is how DNS works. And always remember, whenever you're uh, traversing any site, or wherever you're browsing any site, uh, at the back end, DNS is in action. It is converting your host names to IP address for your clients to reach. And all this process, the iterative process which I mentioned, okay, that is all happening in milliseconds. That means your local DNS server, the exact next DNS server which is there, it will make a lot of queries. It will start from the root servers. There are around 13 or 14 root servers, I believe, which are there on the internet, which have the top level domain records of all the DNS servers of .com, .org, .in, .uk, etc. And from the root servers, the DNS server knows the address of the TLD, top level domain servers. Then they will know the actual domain DNS servers, and then they will know the actual record, www or whatever, download.google.com, or text.google.com, abc.google.com, that will be present on the google.com authoritative DNS servers. So I think we are good. Another tool which you can use for DNS lookup or troubleshooting is also NS lookup, which I forgot to mention. NS lookup. So for example, if we go back to our this, so if I do a NS lookup yahoo.com, it will give me the, it will actually first connect to the authoritative server of uh, yahoo.com and get the addresses, but it will also first connect locally to the DNS server. Let's see what happens. Okay, so when you did a NS lookup, this is the local DNS server which it connected, and then this local DNS server actually went ahead and did iterative queries and got a non-authoritative answer for yahoo.com. That means in between from the intermediary DNS servers, it got the records. So yahoo.com has multiple server IP addresses, in fact, over the internet, and anyone you can connect to reach to the yahoo.com. But of course, we saw that yahoo.com does not allow directly access via IP address. It somehow restricts you and takes you to another page. Okay, so NS lookup you can use for troubleshooting. There is a difference. See, when you use ping for anything, this ping can also connect to your uh, cache and host file, by the way. That this difference people don't know, but you should know. Okay, so when you do a ping, it will resolve, but before resolving it will go to the cache also, it will go to the host file also. But if you do a NS lookup, okay, then it will directly hit the DNS server only. It will bypass the host file and the this one cache. So that's the difference. Oh, there is a typo. NS lookup. Okay, so I think that was it for DNS. Thank you. Thanks for watching, and if you like the video, please do give it a thumbs up and do subscribe to my channel. Thank you. Thanks a lot. Bye bye.